Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and sometimes in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. Before we get into today's episode, a very quick pitch for our online Writing for Impact and Influence science writing course, which is taught by yours truly and is starting this July. The basic idea behind the course is to help scientists improve their outreach and professional writing with a real focus on actually preparing publication-ready work. You should leave the course with several pieces that are absolutely ready to submit and share, and there's a link in the show notes for more information. But you can also feel free to send me any questions about the course at bioscience@aibs.org. Moving on to today's business, this episode is the next in our In Their Own Words oral history series, in which we talk with scientists who've made great contributions to their fields, particularly in the biological sciences. This week's guest is Judith Weis of Rutgers University, and she's also a past president of AIBS. Let's go to the interview. Dr. Weis, thank you very much for joining me today.
I'm delighted to be here.
Okay, just to get us started, when did you first know that you wanted to work in the life sciences?
I'm not sure I actually knew I wanted to work in life sciences, but when I was 7, my parents rented a house near a bay beach. I spent a lot of time at that beach, and I ran into, walking in the shallow water, a large hermit crab inside a large whelk shell, and the shell had barnacles and algae and all kinds of things attached on the outside. And I watched this thing walking, and I thought it was just the most amazing thing I ever saw. And my friends and my mother were much less enthusiastic about it than I was. I didn't then, at the age of 7, decide that I wanted to study life sciences, but that may have been a formative experience. And when I was a senior in high school, I took AP biology, and that sort of, at that age, then kind of decided me that I wanted to be a biologist.
Moving back to that first beach experience,
yeah.
Where was that bay?
On Shelter Island, New York. Shelter Island is a pretty small island in between the North and South Forks of Long Island. So it's reached by ferry from either direction, the North Fork or the South Fork.
Was there anything in particular about that AP biology teacher that drove your decision-making, or was it just the material? He
was a wonderful teacher and had a wonderful sense of humor, and everybody just adored him. And he also just made biology so fascinating.
What would you say is the biggest surprise of your career?
Well, I have to back up a bit to lead into what the surprising thing was. There was a few years where we were studying potential effects of pressure-treated wood. Now, pressure-treated wood is wood that has been loaded with chemicals to deter rot. It's put in the water. It's also used in some telephone poles and bulkheads and pilings and so forth. And the form that's put in the water is really loaded with the chemicals. The chemicals are a combination of copper, chromium, and arsenic. And the companies that made this stuff declared it was no risk because nothing leached out of the wood, and they declared that by analyzing the wood, which is loaded, huge amounts of these 3 metals, and then they had it in the water for a while, and then analyzed the wood again, and saw the amount of metals hadn't gone down. Now that's when you've got such a high concentration, you can have very toxic levels leach out and never notice it in the wood. What you have to do is measure what's in the water after you've done that. And so we did a bunch of studies looking at the toxicity of this, both lab studies and field studies. And we were publishing this in referee journals, and they were very annoyed that we were daring to say that their product was hazardous rather than perfectly fine. And I was going to present this some of our work at a meeting called the Shallow Water Conference, which focused on, shallow water, obviously. And we came to the hotel that the conference was in, and I saw on the board that there was the Wood Preservers Association also meeting at this same hotel. And that was no accident. I'll tell you, they were there on purpose. And that was a big surprise. But their knowledge of science was so rudimentary. They came, usual biologists conference, people are dressed in jeans and T-shirts and stuff like that. And there was lining the back a bunch of guys in suits. So it was clear who they were. And they tried to challenge me by asking me, did you use controls? Now that I think they thought was a very sophisticated question. And anyway, the surprise was finding them there. They did not intimidate me. I think maybe if I had been much younger, starting out in my career at that time, I might have been somewhat intimidated. But at that point, I was not intimidated at all. The surprise was finding that they had actually decided to have their meeting at the same hotel with the Shallow Water Conference.
That's amazing. So was their entire purpose in having it there then just to intimidate the members of the Shallow Water Conference, and you in particular?
Well, I think it was focused on me. I don't think there were no other presentations about treated wood at the conference. So they did not say we decided to meet here because we wanted to harangue you. No, they didn't say that, but it's obvious.
But they were in the room. That sounds incredibly surprising and incredibly intimidating, actually, to me.
Well, what the surprise was arriving at the hotel and seeing the list of who's meeting here, seeing that the wood preservers were meeting there. I was not surprised to find them in the room when I was giving my talk. I mean, once I saw they were meeting here, I figured that was what they came for.
Just to follow up the story, have the qualities or additives to that pressure treated wood changed at all over the years?
Well, they have changed it quite a bit. They've taken out the arsenic for use in children's playgrounds, because arsenic is clearly the most hazardous to people. But in the marine environment and freshwater, it's the copper that's the most harmful. And there have been a number of communities and places, localities, counties, communities that will not use, that prohibited the use of this wood in the water. So some changes did get made.
And in the marine environment, was it actually affecting the well-being of the local flora and fauna?
Oh, yes, it was definitely in oysters accumulated so much. In some places, they would actually settle on the wood, oysters. And if you looked at the oyster, you took it off the wood and opened it, there's a slight green tinge to the oysters, which was due to the copper uptake, like the Statue of Liberty looks green because of copper.
That's incredibly alarming. Moving on, though, what would you say is the biggest difference between the way that science is conducted now and the way that it was when you entered the field?
Well, earlier in my career, science was much more of a solo effort, and now it's very few single author papers. They're really rare. It's much more of a team effort. And also, my career started before there were, desktop computers or laptop computers. And we have now at our fingertips the availability of doing very sophisticated statistical analysis and can analyze data in so many much more sophisticated ways than before the advent of computers.
And I've heard similar answers from others on that question. Do you miss it at all? The solo oriented research endeavor.
Oh, I don't. I don't miss it. I think it's can get a lot more done when you have computers and you have teams. I think it's a very positive. And also, people used to think, well, a scientific career is very lonely. You're all by yourself in this lab. And you're not, I mean, perhaps at one time that was a common thing. But nowadays, it's a very rare thing to be all alone. You're very much working in teams, and I think it's all for good.
So you're working in teams with, people both while in the field and the lab, and then also in preparation, et cetera.
Right.
How have professional societies played a role in your career?
Well, I played a very big role. I'll talk about AIBS, for example, since that's what this is about. When I first got involved with AIBS, when I came to Washington in 1983 to be a AAAS Congressional Science Fellow, and I was working, I guess so that involves AAAS in my career also. This is a program that brings professional scientists into Washington to work in Congress or in the executive department agencies. Back then, it was mostly working in Congress. And I was working in Congress, and I got a phone call from Charles Chambers, who was then the executive director of AIBS, probably before your time, right?
Yes.
You haven't been there. This was, in the 80s. And he called me and he said he had gotten the list of fellows and saw that I was a biologist. And he invited me to come over and talk and invited me to some meetings of AIBS that were happening around Washington. And that's what sort of drew me into AIBS. And then I later, ran for the board and later became president. So I thank Charles Chambers for that initial work to connections for AIBS. I've also been quite active on a bunch of different committees with the Ecological Society of America. I've been active also with now it's called Coastal and Estuarine Research Federation. And I really enjoyed working on committees of these various societies to get them more involved in public policy. Back at that time in the 80s, AIBS was much less involved and the Ecological Society was much less involved. And I was on committees encouraging both these societies to establish congressional fellow programs of their own to coordinate, to be part of the AAAS system. The AAAS fellowship program is not just funded through AAAS. There are professional societies, the American Physical Society, the American Chemical Society, the American Psychological Association, and various engineering societies send fellows that become part of the AAAS, and they are funded by their home society. And there was no biological society that was contributing to this. So I did have, for a while, AIBS and ESA sponsoring fellows into the program. They since have discontinued that in favor of having a hired staff in their office doing the public policy work. And I can see from the point of view of the society, they probably get a bigger bang for their buck of having their own professional staff rather than sponsoring a fellow who they can't control. The fellow is working on whatever their office is doing. So a society sponsoring a fellow is doing a big service to the community of scientists, but not necessarily getting the payback that they get from having their money paying their own staff member. But for a while we had that, and in any case, the societies did, in one way or another, get much more involved in public policy, and I think I had a little bit to do with that.
It certainly sounds like it. What issues were you working on at that time? That was a little bit before the Clean Water Act amendments, was it not?
Well, they were being churned around. They weren't. We talked a lot of talk about, and a lot of meetings talking about Clean Water Act. But I ended up working on the Resource Conservation Recovery Act, RCRA. This is with groundwater pollution problems. There was also the Safe Drinking Water Act amendments. These were not issues that I had been very involved with before. I had been dealing with water pollution in terms of, marine animals. But I walked into the office and they said, "You know about water pollution, right?" I said, "Yes." And so they handed me a big stack of things about the Safe Drinking Water Act, which I had never heard of before. But I read up and you can learn. So I learned a lot about groundwater and drinking water issues that I hadn't known before. And that was great.
And how long were you in D.C. for?
Well, I was in D.C. that 1 year as a fellow. And then a few years after that, I came back to DC as a rotator at the National Science Foundation. And a couple of years after that, I came back to DC working at EPA. So I kind of fell in love with Washington, DC for a while and spent a total of almost 4 years there, one way or another.
What was your most challenging day on the job?
Okay. When I was an assistant professor, I was teaching in the general bio freshman class, as was a colleague who was also a male colleague who was also a junior faculty member. And in our department, there had been a tradition that the beginning people, starting off assistant professors, had biology, had to teach the general freshman course, which meant that it was not viewed positively by any of the people who taught it. It was sort of what you had to do at the beginning. And then you got a little more seniority and you didn't have to do this anymore. And we both thought this was not a good way of doing it. There are people out there who like to teach freshman course.
Right.
And we agreed that our department, the next person we should hire should be someone who really wants to teach general bio and will make their career teaching general bio, rather than this sort of foisting it on whichever new person hires for doing something else. So he said he would write a letter, draft a letter, and we would send it to our department head. So he drafted a letter explaining all this, and he said, the person should be a man, and et cetera, so forth and so on. And I was shocked. I said, the person should be a man? Why? He said, running the course requires, doing a lot of administrative work, and women can't do that. And I said, well, some women could, some women couldn't, some men could, some men couldn't. And then he said, well, running this course requires getting the respect and cooperation of this group of graduate students who are teaching in the labs. And I said, well, some men could, some men couldn't, some women could, some women couldn't. And by this time, I was furious. And I had never been involved in the feminist movement before this, but this conversation, in addition to making me very angry, greatly raised my consciousness, as was the term we used back then. And I went home steaming, furious, and saw in the paper that there was going to be a NOW conference in New York City that weekend. And I took myself to that NOW conference and came home with a huge stack of papers. And it just changed my life. I got involved in the women's movement. And so in a way, I owe this guy a very important part of my life, which has been working in the women's movement and in academia and elsewhere. And it was all because of this conversation, which at the time was a very distressing, challenging conversation. But it led to a very important and positive aspect of my life.
Yeah, it's amazing to me to hear that someone would have ever said something like that at all.
Yeah.
I mean, it's just absolutely preposterous. But I gathered that that was somewhat common.
This was the early 70s,
Gosh, even in the early 70s, I would have expected better. But I suppose
I would have too. I mean, I had actually never run into that kind of sexism or discrimination. At least I was totally unaware of it if I had before that.
How did you experience that issue in academia? I think that there's often, a tendency to think of universities and other, academic outlets as being, places that are generally more liberal than a lot of others.
Probably it's better than trying to work in the construction trades or something. Yeah. But I experienced more problems with my contemporaries as assistant professors, the people I was kind of my generation in some way competing for who's going to get promoted and that sort of thing, than I did, at least overtly, from the senior men in the departments. My department was unusual in that there were other women there before me. There were 3 other women that were in this department, and it wasn't that big a department. 3 other women who were there before me, one of whom took me under her wing and was extremely helpful as a sort of mentor getting, in the university system. She wasn't at all in the same field of biology, but she was very helpful in terms of navigating around the university.
And that's been something that this sort of work is something that you've carried on throughout your career.
Yes, I have.
With involvement with NOW and other organizations?
Well, with NOW, and then for some time I was involved with the Association for Women in Science, AWIS, which focuses on science. And then also NSF has had a program called Advance, which is grants for supporting women. Some of the grants focus on students, some of them focus on faculty development. And I was a co-coordinator. Rutgers got a grant from this program that was a 5-year grant, and they had coordinators. I was not part of applying for the grant, but once the grant was obtained, they needed coordinators in the different campuses of Rutgers. So I was a co-coordinator at the Newark campus where I am, and that was very rewarding. Being able to support junior faculty, assistant professors, enabling them to getting them some travel money to go to conferences to present their work, helping them if they were running into publication costs, things like that. It was really rewarding to be able to help our junior faculty out.
Do you have any favorite stories from your time working with AIBS, either early involvement as a board member, as president?
Yeah, when I was president, it was after the time that the AIBS annual meetings involved, bringing together the American Botanical Society and Ecological Society and all those smaller societies. You weren't there yet back then, were you?
I don't think I was, no.
No. I mean, back in the day, AIBS had a huge meeting because it was coordinating meetings of member societies at the same place at the same time. So people could be attending sessions sponsored through the Ecological Society or American Botanical Society or the Fern Society and these other societies. that had stopped because ESA decided to go their own way and have their own meetings. And then the American Botanical Society did the same. So then there was nobody to be coordinating meetings. So AIBS for a few years ran its own smaller meetings. And that was the situation the year when I was president, it was 2001. And I had been also very concerned with efforts to try to get creationism into teaching in the public schools, things like that in parts of the country, and decided we needed to have a evolution as the theme of the meeting. And I got all the big shots to come. Ernst Mayr came. E.B. Wilson came. Stephen Jay Gould came, and he was very ill at that time. And I believe his talk, we gave him an award. I don't remember if he gave a talk or just came to get the award. And that may have been his last sort of professional public appearance, because he died a few months after that. But I was very, very pleased to run this conference, to have put together this conference with all, lots of the bigwigs in the field of evolution, which is not my field, but I appreciate its importance.
No, that's an incredible collection of luminaries. What's the funniest single thing that's happened in your career?
Okay, so with this, like the other one, I have to sort of back up and lead into it. In the 70s, middle 70s, the product Tang, this powdery orange juice stuff?
I'm very familiar with it, yes.
You are familiar with it, okay, because you don't see it around much anymore in the stores. But they were having a series of commercials they first had astronaut commercials. And after they ran astronauts brought Tang up into space with them because, it's a powder. Then they ran a series with women scientists who had cute kids. And this was a series that went on for a couple years. And I found myself, I learned that they were looking for women scientists with cute kids, which I did have cute kids. I went into New York to have an interview and showed them pictures of the kids and all of this, and ended up making a Tang commercial for which they paid first-class airfare, which I never had before or after, to fly to Los Angeles and go out on this beach in the Los Angeles area with the family. And they had this script of what I was supposed to say. And so this was like a very different thing to be doing, not your typical thing that a scientist does. We made the commercial, and my colleagues in my department knew all about what was going on, what this was about. And when I came back afterwards, they had a little party, surprise party, and presented me with an orange juice squeezer. That was a funny thing. Very clever. And that commercial ran for a couple of years, and actually, and this is also funny in a way, there was the first year it was running, I made more money from this commercial than I made from Rutgers. The commercial was like 2 or 3 days worth of work compared to a year's work of teaching and research at Rutgers, and I got more money out of the commercial because they showed it a lot, get all this residuals. So
that is an incredibly funny story. I had no idea that you had a history in television commercials.
My show business career, right?
Okay, so other than your run as a Tang advertiser, what event from your career do you think will be most remembered long into the future?
That's another tough one. I don't know that my name being associated with things will go on far in the future. I think certain of the research that I did has led on to a growing field, but the field keeps growing and it's no longer referencing how it started. So, but I feel good about that. We were one of the first people that showed that fish living in a contaminated environment could evolve basically to become resistant to some of the contaminants. And we were looking at mercury and found resistance to it in the population from a polluted environment was much more resistant than a population living in a clean environment. Now, this work has gone on to focus on resistance to organic pollutants like PCBs and dioxins and stuff, and now it's going into looking at the genetic changes. So it's gone far away from our original work, but I think, we kind of was at the ground floor of that. Other stuff that I've been involved with, again, it's not my name so much, but I've done important work on scientific advisory committees for EPA, for New Jersey Department of Environmental Protection. I'm currently chairing the Science Advisory Board of New Jersey DEP. I was for about a decade on the advisory board for the National Sea Grant Program. And I feel very good about the work on these advisory boards. I've also contributed to the UN a number of reports that the UN, the famous one that everybody knows about is the IPCC, the Intergovernmental Panel on Climate Change. That there are many others that don't seem to get the press that IPCC gets. There's the Global Environmental Outlook, GEO, and I worked on 2 iterations of that. There was GEO5 and GEO6. There's also the Intergovernmental Panel on Biodiversity and Ecosystem Services, IPBES, and I worked on that. And there's also a World Ocean Assessment, and I was involved in coordinating the salt marsh chapter in the World Ocean Assessment 1, and we are currently working on World Ocean Assessment number 2. And again, I'm chairing the writing group for salt marshes. So at least I hope these things will be remembered and effective in the future. I can't be sure they will, but I hope they are.
I would certainly imagine that they would be. What's the most frightening or intimidating thing that's happened to you in your professional career? You've already named a couple of candidates, but anything else?
One of the early graduate students that worked with me is a short woman, about 5 feet tall, little. And we were going out in the field into an estuary, and the mud in the estuary it's not quicksand, but it's not that different from quicksand. And she, you're wearing boots and stuff, and she started sinking down into the muck and couldn't get out. And that was pretty scary. And finally somebody got a rope to throw to her, and we pulled her out. But before the rope got out, it was pretty scary thinking that I'm going to lose this little graduate student in the mud, Newark Bay of all places.
Oh no, I'm a kayaker, and I've occasionally mistimed tides and been in a very similar situation.
You know what that muck is like, right?
Yeah, I don't know if what we have. I'm on the Chesapeake Bay, but I don't know if it's the same type of muck, but it is impossible to get out
Yeah,
of.
black mayonnaise it's called sometimes.
Oh, that's fun. I had no idea of the term, but I have to say I'm not a big fan. Moving along, what are you working on right now?
Well, I'm working on a whole lot of things. Despite the fact that I'm in my 10th year of retirement, I don't really feel retired. I'm working on a bunch of projects. The two biggies are salt marshes. I'll talk about salt marshes first. I've studied salt marshes. I wrote a book about salt marshes, and it's one of my passions in this world are salt marshes. Salt marshes are known to be very valuable as homes for lots of animals, fish, crabs, shrimp, mussels, and so forth, as well as birds and some mammals. And they're habitats that are intertidal. The tide goes up and then the tide goes out. They're intertidal habitats. And they're important for people also. Salt marshes protect people from flooding and storms. It acts like a buffer when a hurricane comes. So there's been studies showing that the existence of salt marshes gives less damage to houses and towns behind them than if they didn't have a salt marsh there, if hurricanes and coastal storms come through. So these are really important habitats, and they're at great risk these days from sea level rise. When it's an intertidal habitat, the sea level is getting higher and higher, and if nothing changes in the marsh, it will eventually become underwater completely and cease to exist. It will just drown, basically. So what a marsh needs to do is either increase its elevation by adding more sediments and plant debris on top so it gets higher along with the sea level, or it could, if it can, move inland, just move up the slope. Now, many of the marshes in the mid-Atlantic and New England area are not keeping up. They are not getting enough new sediment to rise up as fast as the sea level is rising. So with them, the alternative is to move inland. But, if you're in an urbanized area, there's nowhere to go inland because there's roads and towns there. So the phenomenon someone has called this coastal squeeze is the marshes are susceptible to the. So that's what I spend a lot of time worrying about is the fate of salt marshes. And I've been, in the World Ocean Assessment, we talk about this. I'm part of a committee, actually chairing the committee for the New Jersey Department of Environmental Protection, looking at how are the marshes in New Jersey doing. And from what we've learned so far, most of the marshes do not seem to be keeping up. And in New Jersey, particularly northern New Jersey, the highly developed part of the state, there's very little opportunities to move inland because it's all developed. So that's one of the I'm writing about this and trying to work to figure out, what possible management options there would be to enable marshes to continue existing through this century. Another thing I'm working on is the issue of microplastics. Are you familiar with that at all?
Yes, I am.
The tiny little pieces that may be coming from breaking up of, plastic water bottles or, other small pieces, or a lot of them are coming out from washing machines when people are washing synthetic clothing. Fibers, synthetic clothing are releasing thousands and thousands of these very thin, small fibers. into the wastewater from the washing machine that ends up going out through the sewage treatment plant, which captures some of them, but then a whole lot of them are going out into the water. And I'm not doing any basic research. I don't have a lab anymore, but as a sort of senior level person, I can look over a developing field and comment on it and make suggestions for how to improve what goes on. So I'm following this issue very closely and writing up papers on how we should improve this research. I'm also working in environmental activism. I'm a longtime member of the Sierra Club. I'm part of the Sierra Club has various teams of people from all over the country focused on different issues, and I'm part of the marine team, and I'm active with the Sierra Club Marine team, and also with my local New York City group of Sierra Club, and also with a local group called the Plastic Free Waters Partnership, which is a coalition of people and other environmental organizations that are interested in reducing the amount of plastic that is getting into the environment. And it was just yesterday, by the way, something that we worked on for a long time. New York State now is plastic bag free as of yesterday. Now, there are some loopholes, but the grocery stores and department stores and the big, drugstores cannot give you a plastic bag with what you purchase. DC has had this for quite a while, but we now have it in New York. They don't yet have it in New Jersey, but that's a major victory, and I'm glad I was able to do it. Well, it wasn't me. It was me being a part of a much larger group of various environmental organizations. But there was also, getting back to AIVS, at one time BioScience magazine was mailed in a plastic envelope, and I suggested they didn't need it. And as far as I know, at least the ones that I get doesn't come in a plastic bag anymore. So.
No, and I was going to mention if you didn't, that you led that charge, and thank you very much for that. You know, I'm happier now when the journal reaches my mailbox every month that it's not in a plastic bag.
Yes, I think I wrote an editorial called "No More Plastic Bag."
You did indeed, I'll put a link to that editorial in the show notes and also in the article when it appears. If you were entering graduate school today, would you do anything differently? And if so, what kinds of things?
Well, assuming I would have been the same person with the same husband and having to be in New York City for graduate school, which I was, I would have many more choices, because at the time when I was ready for graduate school, the only option in New York City was NYU. Because there was one faculty member there who studied fish. That was the closest thing there was to anybody, potential faculty sponsor to work with, because the City University had not started graduate programs yet. And Columbia had no ecology or evolution. Columbia was, at that time, all cell and molecular biology. So if I were coming as a starting graduate student now who had to be in New York, I could then avail myself of City University or Columbia, and I wouldn't have had to go to NYU. So I would have done that differently. I would also have probably been a whole lot smarter toward the end of graduate school. In terms of job hunting, we had no advice or anything about how to look for a job, how to make your resume. They have all sorts of things like this available to students now. And I was really clueless when I was looking for a job. Um, and the graduate students coming out now, and my graduate students, I always talk to them, but there were also offices around the university that would help them. And that's something I never had. And it was just luck. I mean, I applied to so many places from community colleges up to Rutgers, and I did not distinguish this in my head. I didn't realize that if I were to have a career at Rutgers, it would be a research intensive thing. Whereas if I were to have a career at a community college or a small liberal arts college, research would be a very minor, if at all. You know, it could be strictly teaching. And I'm so happy I lucked out that I got a job at Rutgers. So I had the opportunity to do research. It would have been a very different and much less interesting career had I taken a job elsewhere.
And I guess it's largely along those same lines. But do you have any advice for young scientists starting out in the field today?
Well, you know, they're starting out in the field with some disadvantages. Well, with some advantages in that they know what to do. They know how to look for a job. They understand the difference between a job at a community college versus a job at a research university. But also they're at a disadvantage compared to me because when I was coming out, there were lots of jobs. They were looking, colleges and universities were expanding, and getting a job was not so difficult. There were lots of jobs, whereas today there are far fewer jobs. People are staying in postdocs longer to try to wait till they can get a job. We have, when our department is hunting for a job candidate, they get hundreds of applications for each position. And so the competition is so much more difficult now than it was when I was coming out. So, you know, there's some differences that are positive and some differences that are negative. But what I would advise people once they have a job is that the job is not their whole life, that they should find time for smelling the roses, whatever. You know, if they have hobbies, they spend some time with their hobbies. They have family, spend some time with their family. Got to have a balanced life and not, you know, have your career be your whole life.
And I think that's great advice for all of us and a good note to leave it on. Dr. Weis, thank you very much for joining me today.
Okay, thank you.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.